So in this case, we're going to consider this function y equals the square root of 4 minus x squared, the line y equals 1, just within quadrant 1 though. So this region right here, I hope you can see it. We're going to revolve that region around the vertical line x equals -2. And the goal is to sum up some stuff. What stuff? Exactly. You got to figure out the stuff that you're summing up that's going to obtain the volume of this region, this solid that's formed when the region is revolved around that vertical axis. Now in this case, I'm going to give you a little framework here. This function, y equals the square root of 4 minus x squared, is actually a semicircle. Now let me take you through that. So imagine a circle of radius 2. Yes, of radius 2. Imagine a circle of radius 2. So from the center at 0, 0, a radius of 2, we see the circle in purple. Any point on that circle, we could create a right triangle, the right angle being right here. And that right triangle would have would be such that we went over x, up y, radius of 2 would be a point on that circle x comma y. Now no matter where I made this, I would have a similar story of a right triangle over x, up y to get a point on that circle of radius 2. Now, if Pythagoras walked in the room right now, that would be weird. But if he did, he would look at that thing and say, well, x squared plus y squared is equal to 2 squared, or 4. X squared plus y squared equals 4. And then just with a little bit of algebra, we could say, therefore, y squared equals 4 minus x squared. Therefore, y is plus or minus the square root of 4 minus x squared. By the way, y is positive up here. So the positive square root y values would give you the top half of the circle. And the negative, y is negative down here. The negative square root of 4 minus x squared would give you the bottom part of that circle, the semicircle at the bottom side. And so altogether we have the circle. But all I want us to think about is the positive root, so the top half. I only want us to think about the first quadrant, and I want us to think about the region that's contained within that semicircle, or now quarter circle in quadrant 1, and the line y equals 1. I'm talking about that little piece right there. It gets revolved around the line x equals -2. Now, if you did that, think about a representative slice. Remember, we're going to slice it up into infinitely many, infinitesimally thin pieces. I've tried to represent here one case. If that one slice was revolved around that vertical line x equals 2, what you would have is a tall cylindrical shell. Now remember, there's nothing inside, and so it's just the wrapper of that cylinder, the shell of the cylinder. And so we want to sum up the volumes of all of it. Now there's, if you can imagine infinitely many slices, there's one inside of there, and there's one outside of there. If you found the volume of each and every one and summed them up, you would get the volume of said solid. Recall, the volume of a cylindrical shell. If you need to watch the video part 1 on cylindrical shells, the volume is 2 pi times the radius. What that is really is, if we open up that cylindrical shell into a piece of paper, the length is the circumference of that cylinder. And circumference is 2 pi times the radius. Times the height, times the width. So if we sum up all of those 2 pi times the radius times the height times the widths from something to something, we will get the volume of the overall thing. So let's go little bit by little bit. Let's talk radius first. The radius of this cylindrical shell would be from the axis of revolution all the way to the edge there. That would be the radius of that circle. So let's talk this through. How far is it from here to the vertical axis? How far is it from here to here? Well, 2 units, because we're revolving around the line x equals -2. So for sure the radius is at least 2 plus a little bit more. And how much little bit more is that? Well, it depends. We know for sure we have 2 units plus this little bit more. And that little bit more will depend on where I slice it. Like if I sliced it out here, that little bit more would be that much. If I sliced it in here, the little bit more would be that much. But that little bit more is always some x between 0 and whatever that is. Whatever that is. We'll figure that out later. So the radius of any one of these shells is going to contain the 2 plus however much x is as x varies from here to here. So the radius is going to be 2 plus x. Now the height of the shell is this distance here. Now again, we just have to do some measurement. I hope you can appreciate what we're doing is just thinking, measuring things. We're not memorizing, we're just figuring out how big things are, in this case the height. Well, let's do this. From here to here, for sure is 1 unit, right? Because this is y equals 1. So 1, we just want this though. Well, this entire distance would be, depending on x, the output would be the square root of 4 minus x squared. So depending on x, this output's going to be the square root of 4 minus x squared to get that corresponding y value. But we don't want all of that, we just want this. So notice, we're going to have to take away that height of 1. So take the y value obtained from the quarter circle here, subtract 1, and we'll get the height remaining. So the height is going to be, take the entire y value, the entire height, all the way up to that quarter circle, wherever we are in between x is 0 and something. Subtract off the 1, we'll get the height remaining. So 2 pi times the radius times the height times the width. The width is just that little change in x. Now, from what to what? The integration limits here are going to be something we got to work on. For sure, our first slice would be when x equals 0. And then we're going to slice, 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 slice until we get to here. Now, where is here? Notice here is where that quarter circle intersects y equals 1. Listen to what I just said. It's where that quarter circle, y equals 4 minus x squared, intersects y equals 1. So we just have to find out, where does that intersection happen? Where does y equals 4 minus x squared, the square root of that, equal y equals 1? What value of x makes that true? So let's square both sides. Let's subtract 4 from both sides. Be careful there, subtracting 4. 1 minus 4 is negative 3. Let's multiply both sides by negative 1. And let's take the square root of both sides. So this circle is going to intersect the line y equals 1 here and also over here at plus or minus the square root of 3. So clearly this is the positive square root of 3. This would be negative the square root of 3 on this side. And so we're going to integrate from 0 to the square root of 3. So what I need you to think through here and pause and ponder and draw, get out some paper and pencil and draw this for yourself if you need to, but you got to see the radius is going to be some measurement from that center of revolution, the axis of revolution, all the way to the particular slice, the representative slice we're speaking of. So 2 units for sure, plus some more, x. Height. We don't want all the height up to that function. We want to subtract off that gap there of y equals 1. Width, little change in x. There it is. Now, this is the year 2020, and setting up the integrals is really where the mental thinking has to come in. Once the integral is set up, we can integrate using technological tools, and this is a case where I'm going to ask you to just use some technological tools. So get on your phone, get on Desmos, get on Wolfram Alpha, whatever else you might find, and when you integrate this, you get about 0.7 cubic units. Don't hold me to that, but it's around 20.7 cubic units of volume. Think through this and then get to work on some problems.